Hello dear students, myself Amit Sharma. Today we are going to discuss topic motion of class 9 subject physics. Motion is the most common phenomena in our day-to-day life. For an example, bus moving on the road, dogs running in the street, etc. Planets revolving around the sun, earth rotates about its axis, all are examples of motion. Most common phenomena. Motion is a very common phenomena in our daily life. So we are going to start our topic. First of all, we will discuss about what do you mean by motion. What is motion? Motion. Motion. When any object change its position with respect to time, or reference point with respect to time, or reference point is known as motion. If anybody, what do you mean by body or object? What do you mean by body or object? Something which we can see or touch. Is known as object or body. So, when any object change its position, or we can say that when any body, we can say also body, when any object or body change its position with respect to time or reference point, or surroundings, we can also say surroundings. When any object change its position with respect to time or reference point is known as motion. Now we will discuss about what do you mean by reference point. It means body change its position with respect to time. Suppose for an example, a person at 12 p.m. point A. After 10 minutes, a person is on point B. It means person changed its position with respect to the time. So we can say that person is in motion. Now we will discuss about reference point. Reference point. It is a point or object which is used to determine something is in motion. Reference point is a point or place. For an example, if we are moving in the street, then with respect to our surroundings, we can change our position. With respect to our surroundings, we can change our position. So we can say that we are in motion. So reference point is a point or place which is used to determine something is in motion. But in our NCERT exercise, in our NCERT book, origin also known as reference point. It means coordinate axis origin is also known as reference point because it also used to determine the position of the coordinates. So this point is also known as reference point. Now rest. When any body does not change its position, point. It means coordinate axis origin is also known as reference point because it also used to determine the position of the coordinates. So this point is also known as reference point. Now rest. When any body does not change its position position, with respect to time or reference point. When any body does not change its position, with respect to time or reference point, then we can say that the body is in rest. For an example, just like that, a book is lying on the table. So book is in rest. Book is lying on the table. Book is in rest. Students sit in the class. Then all the students are in rest, because student does not change its position with respect to time. But a concept is that motion and rest. Now we can say that in the universe, nobody is absolutely in motion or in rest. Nobody in the universe is absolutely in rest or motion. It means motion is relative, not absolute. The term motion is a relative term, not absolute term. Now we are going to discuss about why motion is relative, not absolute. Why motion is relative, not absolute? Why motion is relative, not absolute. Why motion is relative, not absolute? Suppose, by taking an example, a train moving on the railway track. A passenger A sitting in a compartment. A is in rest. With respect to the compartment. Or motion is relative, not absolute, means at the same time a body is in rest or motion, known as motion is relative, not absolute. Or A is in motion with respect to platform. It means at the same time the passenger A is in motion or rest. Suppose if you are sitting in the class, then you are at rest. If we going in the space, then we can see Earth rotate about its axis. Then at that time you in motion. It means nobody in the universe is absolutely in rest or absolutely in motion. So we can say that motion is relative term, not absolute term. Now we are going to discuss about distance and displacement, known as parameters of motion. Distance and displacement known as parameters of motion. So parameter of motion. There are two parameters. Number one is distance, and number two is displacement. Now, by taking an example, first of all, we will discuss an example. A person A move from point A to point B. A person move from point A to point B in a straight line, means path 1. Another person move from point A to point B. First A to M, M to B, path 2nd. Now another person third person, A to Q, Q to R, then R to B, third path. The first path is person moving from direct A to B. Second path, A to M, M to B, and our third path is A to Q, Q to R, and R to B. In all these paths, person covering some distance. Now, distance. It is the actual path length covered by any body. Actual path length covered by any body known as distance. Suppose we are moving in a bus. If we are moving in a bus, it means the passengers sitting in the bus with respect to the compartment, with respect to the surroundings, passenger in rest, but the position of bus change with respect to the time. So, for an example, suppose if we are going to school from our house, then we are covering some distance. But in all the three paths, person covering actual path length. In path first, A to B. Second, A to M, M to B. In path third, A to Q, Q to R, R to B. But a little bit difference is that there is a shortest path also. It means first path is the shortest path. So displacement, it is the shortest path covered by body from initial to final point, known as displacement. Distance is the actual path covered by any body, while displacement is the shortest path covered by any body. The distance is the actual path length body cover, and displacement is the shortest path covered by body. Now, in the first path, person covering some distance, in second path covering some distance, and in third path, person covering some distance. Now, in the first path, we can say that from the first path that distance is equals to the displacement. Now, as comparison to the third part, distance greater than displacement. It means or displacement, distance is greater than or equals to. Distance greater than or is equals to the displacement. Okay, got it? Now, we are going to study about difference between distance and displacement. Before studying the differences, a question comes in our Olympiad exam. The question is that which of the following is universally truth? Number 1, distance equals to displacement. Distance less than displacement. Distance greater than displacement. Number 4, distance greater than or equals to the displacement. Yes, students. What is the correct answer? The correct answer is option number 4. Distance greater than or is equals to displacement. Distance. When a body move in a straight line, then distance is equals to the displacement. When any body moving in a straight line, then distance or displacement is equals. So fourth option is universally truth that distance is greater than or equals to the displacement. If we are talking about numerical ratios of distance over displacement, or displacement over distance. If we are talking about numerical ratio of distance over displacement or displacement over distance, as we all know that distance greater than or is equals to displacement, so on transposing distance upon displacement greater than or is equals to 1. So the numerical ratio of distance over displacement is always equals to or greater than 1. Numerical ratio of distance